All right, guys, let's knock out this test 22 review. Number 1 and 2 are to solve exponential equations, which means you got to do log both sides. So remember, the exponent goes in the front. And with the 2x in front of the log 3 equals log 26. I'm going to divide both sides by everything, by log 26 over 2 log 3. And as a matter of fact, the numbers in front of log 2 log 3 really makes that log 9. Remember, 2 is really the exponent on the 3. So I'm going to take my calculator and punch in log 26 divided by log 9, and looks like I'm getting 1.4828 right there. Let's go to number 2. Number 2, same deal. This time I'm going to do both sides. It's going to be a little bit longer. Got x log 7. You can also use ln if you want to. X minus 1, you keep that in parentheses. Log 9. On the right-hand side, I'm going to distribute that x and the 1, make it x log 9 minus 1 log 9. I got to get the x's on the same side, so I'm taking that x log 9 over equals negative log 9. This is the key step right here. Factor out the x. When you factor out the x, it leaves you log 7 minus log 9 equals negative log 9. Now, log 7 minus log 9, you can also write as log 7/9, because remember, subtraction means division, so I'm going to actually punch in my calculator like that. I'm going to go negative log 9 divided by log of 7/9. Enter, and I'm getting like 8.7429. There's 1 and 2. Number 3, 4, 5, a lot quicker here. Still equations though, still solving for x. So remember, we're going to go that base, that power equals that. That's what we're writing. 4 to the 3rd power equals x. So it means x is 64. Same thing here. 5 to the 4th power is x. So I'm going to write 5 to the 4th power is x. Everybody knows 5 to the 4th power, 625. Number 5, one more. Same pattern. Come on now. X to the 5th power equals 32. So I'm going to x to the 5th power is 32, which means really I'm just taking the 5th through to 32 here, which is 2. And there's your equation. Number 6 gets the graph of log base 4x. Asymptote is usually the y-axis, unless it's been shifted left or right. First point is always going to be 1 to the right of the asymptote, unless it's been stretched or something. I kind of missed that. Let me try one more time. 1 to the right. Now remember, I want to make that x the same thing as the base. So I'm going to plug in 4. If I plug in 4, remember log base 4 of 4 is 1. So we're going to go to 4, 1 right there. Connect the dots, something like that. And then over here, tell what your domain is, which is 0 to infinity. What is your range? It's all reals. Where is your asymptote? X equals 0. Let's go another one. Number 7 right here. Number 7's got a vertical shift up 2, but that's not going to affect the asymptote at all. The asymptote's still there. What it's going to affect, though, is my first point. Instead of it being over 1, it's going to be over 1. It's going to be up 2. All right, I'm going to put a 4 in there again because it's base 4 again. Remember, log 4, 4, that's 1. 1 plus 2 is 3. So I put in 4. I got 3. So there's my 2 points. It's going to look just like that. My domain, again, really the same thing. These are going to be the same answers, because the asymptote's at the same place. As long as the asymptote doesn't move, that's going to be your answers for your domain, range, and asymptote. Number 8, what is the domain? Remember, all logs must be positive, so all you do is take whatever they give you right there, that x minus 5, and set it greater than 0. Not greater than or equal to, just greater than, because it's got to be positive, not 0. So it means x is greater than 5, so my domain is just going to be everything from 5 to forever. Number 9. Evaluate. Remember, the word evaluate means find the value. So you're trying to find a 1-number answer. It's number 9. Let's take it a step at a time. The first one says 100 divided by 18. That's going to look like this. 100 over 18 minus log 50. And there's another subtraction. Subtraction means division. So because I'm dividing fractions, I'm going to do this. I'm going to make it 1 log here and go like times 1 over 50. Hope that makes sense, because whenever you're dividing fractions, you keep change flip, which is what I just did. And when I do, I can do this. It cancels right there, which gives me 2/18, which is 1/9. And then, so it's basically asking you here, 3 to what power is 1/9? And the answer is negative 2. The 2 part gives you the 9, the negative flips it, makes it 1/9. Number 10 and 11, use laws of logs to expand. You want to write this as many logs as possible, which is going to be fun. So here we go. What I have first, I got log base 2x plus. Guys, when you have a square root, you can break a square root up into two pieces, which is what I'm about to do right here. So I have plus log base 2 square root of x plus log base 2 square root of z. And don't forget, when you have a square root, it's really the 1/2 power. So I really have log base 2 x to the 1/2, log base 2 z to the 1/2. And remember, the exponents go in the front. So end up with log base 2x plus 1/2 log base 2x plus log, sorry, we got the 1/2, 1/2 log base z, 2 of z. Now, here's the catch. These right here, those two, I can actually add those together because it's 1 log 2x and 1/2, which is 1/2. So I'm going to come over here one more step, and I'm going to put 1/2, which is 3/2 log base 2x plus 1/2 log base 2z. That's a good one right there. Be careful. Number 11, remember we talked about this week when you're writing these things, anything that's on the numerator is going to be positive, anything in the denominator is going to be negative. So I'm going to go that route. I'm going to say log z plus log y, because they're both in the numerator, minus log, parentheses, 2 plus x to the 1/4 power, because it's 4th root. So to finish up, all I have to do is put that 1/4, that exponent in the front. So I'm going to put the 1/4 right there, log 2 plus x. Yeah, and you got it. All right, number 11 and 12 are going just the opposite of what we just did. Use your laws of logs to make it into one big log. So here's what I've got. Well, let's go here first. I'm seeing these two first, which is, let's do the exponents. So that's really 4x cubed. That's going to be x squared minus 3 squared. And because they're all added, you're going to multiply all of those. So I'm going to have natural log 4x cubed, x squared minus 3, and squared. And to be honest, you don't really have to have those in that one big parentheses. As long as you write them all together, you're fine. 13, same kind of deal. First two has an addition sign. They're conjugates, so I'm going to go ahead and multiply those. If you multiply conjugates, remember just do foo. So I'm going to do that's going to be a squared minus b squared minus natural log c squared. Because it's subtraction, to go one log, I'm going to put the a squared minus b squared over the c squared. And there's 13. Empty slide. 14. Change the base formula. What we do change the base is we put, and you could do ln, you could do natural log or regular log here. I'm going to do log 9 divided by log 4 and just punch that in my calculator and see what I get. When I punch that in, I'm getting 1.58496. Darn it. So that's going to be 1.5850. Number 15, the review starts. This says compounded monthly. Because it says compounded monthly, I know it's not PERT. So I'm going, the amount is 15,000, the principal, 1 plus R over N. R is 0.04. N is how many times a year? Monthly is 12 times a year. And my exponent is going to be N times T, which is 12 times 7 here. 12 times 7 is 84. I'm going to punch that in and see what I get. It's like about $19,837.71 for that one. All right, 16 is our weekly rational function graph. In the numerator, take out the 4. Denominator is the same. We're good. So my vertical, let's put all the stuff here. My vertical, whatever makes the bottom 0, which is x looks -2. And my horizontal, because the degrees were the same, is leading over leading, which is y equals 4. My x-intercept, whatever makes the numerator 0, is 1. My y-intercept, if I put a 0 in for all the x's, I get -4 over 2, which is -2. So let's do that real quick. So there's my vertical, x is -2. My horizontal is y equals 4. My x-intercept is 1, and my y-intercept is -2, which tells me that the bottom part of my graph is doing this. I mean, the right side is doing this. And you can plug in your calculator to see what's going on the left side. And when I do that, it looks like the graph's going to be up there. All right, one more slide. 17, 18. 17, maybe the longest one on the test. Here we go, though. There's my zeros, -2 and 2 plus I. Had this problem maybe a couple times. -2 comes from here, comes from x plus 2. 2 plus I comes from x minus 2 plus I. And then don't forget one more thing. If 2 plus I is a solution or a 0, so is 2 minus I. I wrote that again. 2 minus I. So I'm going to go x minus 2 2 minus I. So I have x plus 2. If I distribute that minus sign through, I get that. Distribute the minus sign through, I get that. What I've been trying to show y'all, these are conjugates. I have x minus 2, and I have a negative I and a positive I, so I'm doing foo. All right, x minus 2 times x minus 2, and then I times negative I. Keep on going. If I do square, multiply double square, I'm getting x squared minus 4x. And I would get a plus 4 here, but that I squared is also going to be a plus 1. We all know 4 plus 1 is 5, so I'm just going to make that a 5. Now, 2 more steps. I'm going to take this x right here all the way through the second parentheses, x cubed minus 4x squared plus 5x, and then take the 2 through 2x squared minus 8x plus 10. So, final answer, finally, x cubed minus 2x squared minus 3x plus 10. All you got to do on that one, okay? No big deal. Just kidding. That's a lot. Number 18, last one. Oops. Here we go. There we go. Number 18. It says, given this one, find all the zeros and factors. So let's find the zeros first. So you can factor that the way it is. I'm going to say x squared minus 2 and x squared plus 1. Now, I know x squared minus 2, 2 choices here. You can take both of those over to the side somewhere, like you can do this, x squared minus 2 equals 0, x squared plus 1 equals 0, and just move the 2 over, move the 1 over, take square root, solve them that way. Or, that's the difference of squares. Even though 2 isn't a perfect square, it does have a square root, and it's the square root of 2. So I'm going to go x plus square root of 2, x minus square root of 2. We talked about this a few weeks ago. If you have a sum of squares, you can now factor that with I. So x plus 1i, x minus 1i. And guys, if you do it that way, that's part B. That right there is the answer to part B. Factor, completely, just did it. Part A said find the zeros. Well, the zeros are plus or minus square root of 2 and plus or minus I. So that's actually the answer to part A. All right, so if you'll do it that way, you have it all done at the beginning. So hope that helps. Hope you study hard. I think you got a good chance to keep on doing. Their tests have been great lately. Keep that going. I'll see you tomorrow.